Our next speaker is Mr. Anil Bhise, Senior Manager, Product Marketing in Factory Automation and Industrial Division of Mitsubishi Electric, India. He has over 18 years of experience in marketing and business development and project execution in the automation industry. Anil has extensive knowledge of the manufacturing process in industry verticals such as automotive, power, oil and gas, water, infrastructure, and is currently working on a few MES projects. Please welcome Mr. Anil Bhise onto the stage.
Good morning, everyone. I'm Anil Bhise. I'm from Mitsubishi Product Marketing Group, taking care of product as a product marketing. And today I'm going to present on a real story, implementation of IoT at one of the factory of Intel, and how it has been served them to save some kind of a failure, losses due to failure, where the component cost is very few, like 90 cents, but then the benefit of that, of implementations, is quite high on that. Okay. Before beginning to my presentations, I would like to apologize you that generally these kind of presentations we do with our Intel partner, but due to some circumstances, my Intel partners is not available today. So today I'm going to take you, has got the things like they have a productivity, they have a tremendous pressure to improve the productivity. And with the implementation of this asset and then analytics, and they are able to maintain those productivity of the plant. And the benefit of the major benefit of it is basically a 9 million USD per year. So that is the measurable benefit of that. Okay. So let us see how it is implemented. Okay. This is the Intel factory where they are manufacturing different electronic goods over there. It could be laptops, drives, servers, their netbooks, visual computing, their embedded systems, healthcare systems, consumer electronics, and lot many. There are near about 100 plus products they are manufacturing in this particular factory. And there are near about 2,500 line items in this factory to assemble those products. Okay. There are about 65 MU CPUs and the chipsets to assembling these kind of finished products, and more than 400 tools to assemble those chipsets or to assemble those components. Okay. There are different kind of packaging systems or the fabrication technologies that they have to implement. So from this, you can basically experience what big factories there and what complex manufacturing systems they have in this particular factory. So they have implemented this MES IoT systems over there, and then they have the different systems. So few cases they have mentioned over here. First case is basically the automated test equipments. The second case is their ball attach machines, or third case is their metrology systems. So the data has been collected from those systems and given to a central cluster of a data center, and then further it is given to their factory floor data analytics software or the database server, where it can be a process on some typical analytics softwares, and further the data has been transmitted to the cloud data centers. So let us go in detail of those cases. The first case is of automatic test equipments. This automatic test equipment is nothing but testing those components, those devices, for their healthiness, for their go, no-go kind of things. So those components are there good for the manufacturing or not, like that. They have implemented the automatic process of that. So there is a process controller for those kind of machines. And there are basically these components are kept or carried by some kind of a test equipment, some kind of a interface units. They call it as a handler, to pick those components from the conveyors, to pick those components from the bins and place it on the different machines to test those components. So a lot of problem has been occurring in this particular handlers or these test machines. Okay. Because of that, because of those failure of those components, they have identified that there are a lot of good components are getting rejected, or sometimes the batch of the component is getting rejected, which is occurring a huge loss in the productions. Second thing, there is, because of the unwanted stoppage of those machines, there is a production loss. Okay. To implement that, they have implemented some kind of a time-based preventive maintenance on that. But in a time-based preventive maintenance, we generally know those are components is getting replaced with periodic time. But sometimes those components are good and they can be worked for the more longer period. But in preventive maintenance, those are getting replaced. So that is another loss. So what Intel has done, we have implemented the IoT in those systems. We have implemented different sensors to those machines to collect the information, to collect the information and feed it to the data center where the analytic software is working. And with this achievement, they could be able to predict 90% of those basically potential failure of those machines before that get fails. So with that, they are able to achieve the unwanted failure or unwanted rejection of those components or the batches which are good. Second benefit of that, basically they are they have work on that unwanted stoppage of the machines. So the production loss they would be able to recover. Third, with a predictive maintenance kind of a predictive applications, they could able to analyze that which component is going to fail, and they could have some kind of a preventive maintenance or planning of those maintenance in advance, so that there could not be any losses due to this maintenance or due to this failure of these components. So this is the first case. Second case, similar to it, that is for ball attach machines. This is the general soldering machines which you can find in any electronic good manufacturing systems. So where the soldering balls are kept pasted on the printed board, and the entire assembly of that moves in an oven. So where the soldering balls are getting melted and taking care of those positions at near the leads. And with the vacuumizing positions, vacuumizing pressures, it takes care its own place near the tiny hole of the leads. So this is general process of that. And after that, the printed board are getting visualized by the vision systems. And many times they have found that some balls are missing, some soldering balls are missing in that. Now this could be happen with many different ways. There could be a component failure in machines. There could be some kind of a sensor failure, the sensor of temperature or the pressures. So these data also they have collected in the implementing of IoT. So they have collected those data, feed it to the analytics softwares, and get the feedback from the analysis software to the control systems, so that which components or which machines they can have some kind of a predictive maintenance on that. Third case is a little bit different. This is basically the vision system monitoring or vision system processing unit, where the component is, they have taken the image of the component and then it is tested on the go, no-go kind of thing. But many times the image is giving some parameters which are just outside the boundary, but then it can be in their permissible limit. But this inspection, after that, they are doing it manually, and which is consuming a lot of time, lot of energy for that, and for that the production is hampering. Okay. So with this implementation of the IoT, what they are able to do, they are able to process those image in a grayscale and to the digital form. Once the data is available in the digital form, it is very easy to compare and can have those kind of with a different modeling, can have those kind of a decision from the systems, whether that PCB board or printed board or particular component can be reused or can be used for the productions. So these kind of implementations they have done in this factory. Okay, it looks very simple on the front, but then please believe on me, there are so many sensors, and it's a very difficult task to collect those information from the different sensors. The data coming from the sensors are in a different format. Some data in a structured format, some data in a semi-structured format. Some data is basically unstructured format, like images. So those they have to maintain. Those they have to maintain and then process those data. So let us talk about the overview of the system, in which, as I said, there are different machines which are shown. So those machines are communicating to the industrial database server through their manufacturing network, sometimes directly, or sometimes they used to have some kind of a gateway in between to transfer those data to the manufacturing systems or to the central database center. So where the data has been processed, data has been structured, the semi-structured data or the unstructured data has been converted into digital format, and then that has been stored in a structured format. Those data, then further they have transferring to the data centers on a B2B. So where they can have those kind of analytics software, which is working on that. Further, that can be communicated to the B2B clouds. So this is the system overview. Okay. So you must be having so many questions on that, but then we have some kind of a agreement with the Intel to have a non-disclosable agreement with that. So many informations like machine details, component detail, sensors detail, which we may not be able to present you. But then those more information is available on the white paper presented by the Intel, and which is available on the below link mentioned over there. You can download and you can go through it for the more information on it. Okay. But talking more on the systems or what are the solutions which we are provided. The solutions which we are provided in the basically lane of 3 stages. The first stage is collect the data, collect the line data. Okay, there are some kind of control systems controlling that, collect those informations, and then capture processed data has been processed, and then have a time stamping by performing a SimSniper software, which works on a C language controller from the Mitsubishi. Okay, and sometimes this C language controller is also acting as a gateway for the data. Okay. So there are two functions. One is basically collecting those data directly or indirectly through on a CC-Link IE kind of network. Okay. Further, these data can be transferred to the basically data management center through the SEX communication, okay, where the revolutionary R analytics and share the local cloud on a ABS space. Drilling down further how we capture the data, how we have processed the data, we have used a C language controller of a Mitsubishi. This is nothing but a standard C language controller mounted on a base rack of a Q series with a power supply and different cards. But then program which is developed in a language C or C++ can be processed on it. So very secured way of processing those kind of a program. Okay. And there are near about 3 stages of collecting those information. One is basically can communicate directly to the machine and can have those data. Or we can have some kind of analog input modules which is communicating to this particular CPU. Third, we can access those data through the network of a CC-Link IE. So we can capture those kind of a field bus data on a CC-Link IE network. The second stage of it, the C language controller, which is performing some kind of a test over there, like IoT gateway, or there is some kind of a host SimSniper software of a Nippon demo, which is working as a small data applies a time stamping and make it initial processing of those data on that. And the third one is the processing of the data. The data is received with the system specific, the Fusionix, which is the revolutionary R data analytics software using the various statistical models that has created to interpret those data. Okay. This is the 3 level of the basically approach. So we have seen so many different alliances, so many different companies like Nippon Deno or Fusionix. So how it works? So Mitsubishi has initiated some kind of a e-factory alliances. So e-factory alliances is nothing but a concept. It is nothing but a concept and philosophy to create which can the solutions can be delivered to the IoT or the Industry 4. Okay. It is nothing but basically the alliance of the different manufacturers who can have expertise on those fields, and we can jointly provide some kind of solutions for the industry. So let us see what kind of those partners we have in e-factory alliances. The first one is Fusionix. Fusionix basically has got the revolutionary R, a data processing, which is from the US, and it has got the well features like stamping of those data, trending of those data, different modeling of those data is possible with this kind of software. Okay. This allows data to interpret, interact, and visualize those data, whether it is that. It has got the many existing statistical models, which is developed by the different academies, and we can have a subscription of it, or we can have a service-based contract with those. And nowadays, it is getting more and more popular on that. So Microsoft has initiated or intended to buy this revolutionary R, and that is they have declared somewhere in the Jan of this year. Okay. The next alliance partner is Nippon Deno. This is basically the collection of the analytical software, collection and analytical software. They call it as a SimSniper, okay, which has got the many functionalities and the features, but the main is easy to use on a configuration tool. Okay, independent of a machine program, and they have the basically MES data or field data on the status of the machinery or the production status can be monitored, and a time control protocol on a NTP. These are the few additional benefits of this Nippon Deno. Okay. Talking to the another partner, definitely Mitsubishi is one of the partner of that, and Mitsubishi has got an automation platform for these kind of solutions where we can use a C language controllers, a IQ automation platform, or a CC-Link network for that. And a C language controller, talking about the C language controller, it is a standard CPU which can be mounted along with other CPUs on a standard base rack. Okay? And it has got the multiple functions, like it has got the multiple connectivity, it has got a small display to it, it has got the multiple USB ports, communication ports, 230 ports, Ethernet ports, then a SD card slot to storage the data which is analyzed. So it has got the multiple functions and required for those kind of applications. It is nothing but a CPU which works or which is capable of running the language program developed in a C or C++ kind of things. Okay. Supported that with the IQ platform. IQ platform of Mitsubishi is nothing but a one common platform for all end user. In an end user or that the factory, they may have some kind of a different applications. They may have some kind of a sequence controlling, they may have a process controlling, or robotic controlling, CNC controlling, various kind of applications will be there. But then Mitsubishi offers them a one common platform to control that. One common platform which will have a multiple CPUs, but then the same IO racks or same different accessories can be used for that. The benefit of that to the end user is definitely they have one common software, they have one common platform to get expert on it, which definitely help them to reduce their cost of ownership. Further, it has got the multi-CPU kind of concept. The multi-CPU kind of concept in which the motion CPU or sequence CPU can be mounted on the same base racks, which can have a seamless communications, which definitely helps them to increase or maximize the production capability. Okay. In IQ platform, we have the multiple different modules. I'm not going to mention all those, but then different modules are there like MES interface modules, which can communicate to the MES database or MES software directly without any PC interface in between. So the data from the control systems can be communicated directly to your MES. So these are the few additional modules we have in IQ platform. Supported that with the CC-Link I network. CC-Link I network is a one common network for your different applications. It might be your device communicating, data communicating, or control, or motion control, or safety communications. For all those applications, we have one common network, that is CC-Link IE, and which can be given in a different configurations. A redundant configuration also it can be proposed. Okay. The main USP of that, it has got the tremendous high communication speed that we are talking about, the 1 Gbps. Okay. And there are multiple partners we are developing under our program of CLPA. There are near about 2,200 different partners who are developing their machines which can communicate, developing their equipment which can communicate on this CC-Link IE network. Okay. So with this kind of a network, what is the benefit we are going to get? We are going to get a seamless connectivity from the sensor level to the control level to the MES level. A data captured by the different sensors or the drives can be seamlessly communicated to the control systems and the MES levels. That is on the SLMP protocol. So with that, we can say a new dawn of manufacturing is evolving. So we have the requirement of Industry 4, which has got the highlight of cyber physical systems or understanding the information on the context. We have the IoT Express that needs to share the data on a common interlink way. We are encompassing the activity within and around associate with the target. On the software part, the specific analytics processing software, which was the missing link earlier, to convert those capture big data on actionable informations, modulating those results before the production can begin, understanding and visualizing those links between the different activities, and diagnostic or root cause analysis. So these are the different benefits of that, and I'm sure with the presentations which I have given to you, it is easy to implement those things. So now we can say the clouds of confusion is being cleared. On the result of that, we can have a kind of a three-dimensional approach to that. One is the technology. We have the technology which can have the IoT or Industry 4 works. We have the statistical analysis software which can work. We have the control platform which can be given for such kind of systems. Okay. On the other hand, we also have the